Now that we've clearly discussed how reciprocals create ones, we can see more clearly how to make 1x, or one of any variable, to find out what its value is. So here, in a previous video, we see 5x equals 40. We can use the notation of fractions to divide both sides by 5 and say, well, x must equal 8 because 5 times 8 is 40. This is multiplying by the reciprocal, just showing it with a different notation. 5x is the same as 5 over 1x, or 5x over 1. So we could have shown our work like this, multiplying by 1/5. Multiplying 40 by 1/5 is the same thing as dividing by 5. It's just wordplay. We want 1/5 of 40. If we were to evaluate this, we would end up with 40 over 5, the same way we have it here. And 1x still equals 8. X equals 8. Here, 1/7. Similar idea, we could just multiply both sides by 7 since we have a 1 in our numerator. But to practice understanding this concept, we're going to visualize the entire reciprocal here. This is 7 over 7, or 1x. And this is going to be 7 over 1 times 3. There's an imaginary 1 under this 3 as well. And that's going to give us 21 over 1. 1x equals 21 over 1. 1 times x is simply x. 21 divided by 1 is simply 21. This is a step we won't have to show once we become proficient in solving these kinds of equations. The reciprocal of 2/5 is 5 over 2. Same thing here, we're going to have 5 over 2. This is an interesting one. We have two ways that I see that we could deal with this. We could do 18 times 5 and then divide by 2, or we can do something called cross simplifying, which I'll show you in just a moment here. So let's start by saying we have 1x, 10 over 10x, 1x. We'll just go on ahead and put x here. And I'm thinking, what's 18 times 5? Well, 5 times 10 is 50, and 5 times 8 is 40, and 50 plus 40 is 90. So this is 90 over 2. Remember, there was an imaginary 1 under the 18 that we don't necessarily need to show. We have 90 over 2. That's going to be x equals 45. With bigger numbers, this can be kind of a cumbersome process. So I'm going to show you how if we have 18 over 1 times 5 over 2, we can look across our values here and see if we have common factors. 5 and 1 can't be simplified, but 18 and 2 share a factor of 2. If I divide both of these by 2, I'm saving time from doing a bigger division problem later. So 2 divided by 2 is 1. 18 divided by 2 is 9. So now I can say 9 times 5 is 45. 1 times 1 is 1. So this method could save you a lot of time in the future, but they'll both get you to the same correct result. Over here we have 4 over 3 giving us 12 over 12, or 1x. Same thing here, 4 over 3. We'll look at the long way here first. We have x equals 4 times 20 is 80. 4 times 7 is 28. So we're going to have 108 over 3. So you might want to do some scratch work on the side here and say, what's 108 divided by 3? Well, 3 goes into 10 3 times. 3 times 3 is 9. We have a remainder of 1. Bring down the 8. 3 goes into 18 6 times. So 108 divided by 3 is 36. Or we can cross simplify earlier and say, I have 27 over 1 times 4 over 3. 4 and 1 can't be simplified. They don't share any common factors, but 23 and 3 can both have a 3 factored out. 3 divided by 3 is 1. 27 divided by 3 is 9. Now we just multiply across to see 9 times 4 equals 36.